Hey guys, welcome back. Today let's master Codeforces 2217B-Flip the bit easy version. So basically we're given a binary array and we're given a special index k. We want to make all of the elements in our array equal to k by doing this one operation. This operation is you can choose a range L and R and you can flip all the bits in that range. And you want to make all of the elements equal to k with the minimum number of operations, right? Just output the minimum number of operations. In this case, since this is the easy version, we're only given one k, which is just going to be this third input line in all of the test cases here. And I can just demo how this question works since it's a little bit confusing with the first test case, right? So we have 0, 1, 0. Our pivot, or let's call this pivot. This is our special index, which is 2. So 1, 2. And we want to make 0, 1, 0 become 1, 1, 1. Well, we can do this by selecting the whole thing, making sure to select our pivot. This becomes 1, 0, 1. Mark our pivot again. And then finally, we just need to only select our pivot, and it becomes 1, 1, 1. Right? Now, first thing to notice about this question is that adjacent numbers that are the same don't really matter. So what I mean by that is if we have 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, something like this, doing the operations on this is the exact same as doing the operations on a collapsed version of this, like 0, 1, 0, 1, 0. And we can just show that because this is the case because we want to greedily select our operations in order to minimize it, right? We want to transform as many numbers to be equal to our pivot in one operation as we can. So let's just define the 0 as our pivot. In this case, this would be our pivot. Let's just simulate some flips. We flip all of these, 0, 0, 0, 1, 1, 0, 0, marking our pivot. Now, since these are all good, we will never touch these numbers ever again. We'll select from here to here, 0, 0, boom. This will require 2 operations. Similarly, for this question, we'll just select all of these, 0, 1, 0, and then select our pivot, 0, boom. Same 2 operations. Now, what you can notice from this case here is that we kind of have 2 cases. Our case Our case 1 is pivot in middle. So like here, or like here, the first operation of each of these where we have some digits and then a pivot and then some digits. In this case, we will be taking one from, or like our largest range possible, right? Like I said earlier. And let's also consider all our cases in this form of collapsed string, since it's just easier to deal with, right? In this form of collapsed string, when we do a pivot in middle operation, we get rid of 2, or like we solve 2 numbers every time, as seen here. This 1 becomes a 0 and we never touch it again. This 1 becomes a 0 and we never touch it again. Basically, we solve 1 on each side, right? Now, when you have a pivot on edge operation, that's our second case. It looks something like this, bang, bang, bang. What you are doing is each time you would only solve 1. So if you had like 0, 1, 0, 1, 0, 1, and this was our pivot, each operation would only solve 1. 1, 0. This is solved, but every time we have to select the pivot. So then this would be solved, then this would be solved, and this would be solved, and this, etc., etc., etc. So now this kind of turns into which side of the pivot has more elements, right? Because pivot on middles can always become pivot on edges if the two sides are not equal. If they are equal, then you don't have to worry about it. But pivot on edges cannot become pivot on middles, right? So this question simply becomes a matter of the maximum of the two sides. So for example, this case, our maximum is 1. We always start from, our maximum is 2, since both sides are the same, right? So that would just be our answer. In this case, our maximum is 0 and 1, 1, 2, 3, 4, 5. So I'm pretty sure the answer to this would be 5, right? If I simulate this correctly. Yeah, I'm pretty sure it should be 5. Now, this is basically the solution. However, there is something a little bit tricky about this, which is this works for a collapsed version of our string, right? And we can simulate this collapse, but it becomes tricky because it's hard to track where our pivot index will become after a collapse. It's doable, but it is kind of strange, or not strange, but you could code it, but it's prone to making errors. But there's a much easier way to track this without moving the pivot, right? And the answer is simply counting how many times the numbers switch. So how many times do zeros become ones, and then ones become zeros. And I'll just show you, since I don't think I explained that very well. But for this case, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, with this as the pivot, 0 becomes 1. This is 1 time, so the track plus 1. And then 1 becomes 0, so plus 1. In this case, 0 becomes 1 plus 1, and 1 becomes 0 plus 1. So our left equals 2, our right equals 2. Our answer is simply the max of left and right, which would equal to 2. In this case, the same thing, 0, 1, 0, 1, 0. Our pivot, 1, 2, 1, 2. So max left and right is 2. In this case, exact same thing. 1, 2, 3, 4, 5, and 0. So max 0, 5 is just 5. And that would be our answer. So let's code this up. The first thing what we would do is define our pivot, right? Pivot is P0, since there's only one pivot given in this case. And let's re-index our array, because our array is going to be 0 indexed, but in the problem, as in most Codeforces problems, the arrays are all 1 indexed. So also, whenever we are counting the switches, we should count the first number always. So it's always just good by adding our pivot to the edges to get rid of integer out of bounds errors and stuff like that. So let's define a new array equal to, set it all to 0 at first, times n plus 2. And then now let's copy our array into 1 index array. So for I in range 1 n plus 1. So what this will basically do is say we had 1, 2, 3, 4, 5. This array will define this, but with 2 extra. And then what we're doing right now is filling in all of these. So our I is equal to our I minus 1. And then we will simply fill in these with what our pivot is. So our 0 is equal to our n plus 2, or n plus 1, yeah, is equal to our pivot. There we go. So now if this was our pivot, all these values would be the same. Now we simply just need to count left and count right. So let's define count left equals 0, count right equals 0. Then for I in range from 0 to our pivot, let's check how many times the number changes. So if Ri is not equal to Ri minus 1 or I plus 1, count left plus equals 1. And we can just copy this, change a few things. We would start from pivot and go to n plus 1. And then if our I does, all this is the same, except we increment count to r. And then finally, we just print the max of count L and count R. All right, that should be it. This was my submission. And if we run it, these were all my custom test cases. But if we run it, it passes. And that's what I submitted here. So if this video helped y'all, be sure to like and subscribe. And I will see y'all guys later. Bye.